Okay, let's dive right into this explainer. Today, we're looking at a seriously unique piece of writing by an author who goes by the name The Dusty Truth. And what makes this text so captivating is honestly the sheer whiplash it gives you. I mean, we're talking about pivoting from highly charged modern politics straight into the ancient, profound mysteries of how our universe actually works. So, we're going to map out the author's exact train of thought and look at how they contrast two totally different models of the cosmos, the heliocentric model and the flat Earth model, all revolving around one very specific, kind of mind-bending celestial anomaly.
The source material actually kicks off with this incredibly intense political statement about the surveillance state and the right to life. Talk about an unexpected hook, right? It grabs your attention immediately by stepping right into one of the most contentious debates we have in society today. But just as you're settling in, thinking you're reading a political manifesto, the author pulls off this massive, almost dizzying shift in the very next sentence.
To navigate this whole complex argument, here's our roadmap for today. First, a surprising cosmic pivot. 2, the 20-minute gap. 3, the precession of the zodiac. 4, the heliocentric wobble. 5, the flat Earth view. And finally, 6, an extreme coincidence?
All right, let's hit section 1, a surprising cosmic pivot.
With this single, super unassuming sentence, the author brilliantly drops the earthly debates entirely. Boom. Just like that, they challenge the fundamental mechanics of the heliocentric model, the widely accepted view where the Earth and planets revolve around the sun. It's such a fascinating rhetorical device. The author's basically saying, you think our earthly politics are complicated? Just look up. It completely sets the stage for a deep dive into celestial mechanics.
Moving into section 2. The 20-minute gap.
Now that our eyes are on the sky, the author introduces the core mystery of the entire text. It's based on the sun's annual journey through the zodiac, and it all comes down to a slight, and I mean slight, discrepancy in how we measure time. The whole premise hinges on the difference between the solar year and the sidereal year. Simply put, these are just two different ways to measure one full year. The solar year is based on the seasons, right? The time it takes for the sun to return to the same position in that seasonal cycle. But the sidereal year, that's based on the stars, the time it takes for the Earth to orbit the sun once relative to the fixed background stars. According to the text, these two measurements don't perfectly line up. They're just slightly out of sync. It's just an artifact, the author notes, of how everything works up there in the sky.
So, here is the crucial point. This exact number. The text identifies a highly specific gap of exactly 20 minutes between these two measurements after one full year. When the sun completes its annual journey through the zodiac, the solar year and the sidereal year are 20 minutes apart. Now sure, 20 minutes might not sound like a huge deal in the grand scheme of the universe, but the author uses this tiny, literal fraction of a day as the foundation to deconstruct our entire understanding of planetary movement.
Which brings us to section 3, Precession of the Zodiac. See, those 20 minutes, they don't just disappear into the ether. They accumulate. The author explains that this 20-minute gap, as it stacks up year after year, creates a physical, observable shift in the sky, specifically a 1-degree separation. If you look at the stars right now and then fast forward through time, that accumulating 20-minute difference will eventually push the stars you're looking at by a full 1 degree from your perspective. But how long does it actually take for those 20-minute gaps to add up to a full 1-degree shift? Well, the source gives us the math. To see that exact 1-degree shift in the night sky on the exact same date and time, it takes a span of 72 years. Basically, over a standard human lifetime, the night sky on any given date shifts by a single degree. This right here beautifully illustrates the macro scale of a phenomenon known as the precession of the zodiac, and the author points out that this precession happens in both planetary models. The stars you see on the vernal equinox shift 20 minutes per year. After 72 years, boom, 1-degree shift. Fast forward 7,200 years and the stars have shifted massively. Yet, and this is a huge yet, the summer solstice remains exactly the same. Play this out entirely and it takes 25,920 years for the stars to shift enough to complete a full 360-degree cycle of the zodiac. It's basically a massive, incredibly slow-moving cosmic clock.
All right, let's jump to section 4, the heliocentric wobble.
So any model of the universe has to explain why this 25,000-year cycle actually happens. The author first looks at how the widely accepted heliocentric model accounts for it. According to the text, the heliocentric model explains this by alleging that the Earth has a very specific physical movement. It doesn't just spin nicely on its axis, it wobbles.
Think of a spinning top as it starts to lose momentum. Its axis traces a slow circle. The heliocentric model claims the Earth wobbles in a circle on a 23.5-degree tilt.
The author lays out the reasoning behind this perfectly. In the heliocentric model, the Earth orbits the Sun. Because of that 20-minute shift after thousands of years to see a completely different slice of stars at night, the Earth would have to be in a physically different position in its orbit compared to where it used to be. But here's the catch. If it's in a different position in its orbit, the seasons should change, but they don't. The summer solstice is still the summer solstice 7,200 years later. So the author argues that this wobble theory is injected specifically so the heliocentric model can explain this away. The wobble supposedly ensures that the angle the sunlight hits the Earth stays consistent, saving the seasons, while also accounting for the Earth being in a different orbital position to see those different stars.
Now on to Section 5, the Flat Earth View.
Having deconstructed the heliocentric explanation as kind of a complex workaround, the author totally flips the perspective. Now we're going to see how the flat Earth model handles this exact same cosmic data and mathematical reality. The text states that the flat Earth explanation is, by comparison, incredibly straightforward. There's no wobbling globe, no complex orbital repositioning. The author claims that the 20-minute gap between the solar and sidereal years simply accumulates. Because of this accumulating time gap, you naturally just see a different set of stars by 1 degree every 72 years, continuing until that massive 25,920-year cycle finishes. It treats the whole phenomenon strictly as an accumulating measurement of time.
Looking at the author's core comparative argument side by side, they assert that the heliocentric model is forced into a corner. It can't just say the Earth is turning at a different rate because, well, the Earth is orbiting the Sun. It can't just say the Earth is in a different part of the orbit because that would ruin the seasons. Therefore, the author argues, the heliocentric model absolutely must inject the wobble theory to make the math work. In contrast, the flat Earth model is presented as elegantly simple, just a pure accumulating time gap over roughly 26,000 years without needing any complex injected orbital corrections to save the seasons.
And that brings us to our final section, Section 6, an extreme coincidence?
We've seen the 20-minute gap, we've seen the 25,000-year cycle, and we've seen two vastly different models try to explain it. Now, we look at the author's final, critical analysis of how all these mechanics actually fit together. The author expresses some really deep fundamental skepticism here. They highlight what they see as a massive flaw in the heliocentric explanation, pointing out how perfectly the alleged physical wobble of the Earth aligns with the purely time-based discrepancy between the solar and sidereal year. Think about it. For the heliocentric model to work, this physical wobble must perfectly, flawlessly match a 20-minute time drift, year after year, for over 25,000 years. The source emphasizes why this perfect alignment is so incredibly hard to believe. They point out that these two things, the physical, top-like wobbling of the Earth and the 20-minute time discrepancy of the Sun's travel through the zodiac, have absolutely no mechanical connection to one another. Furthermore, it's not a mathematical microcosm where one just naturally dictates the other. That 20-minute difference isn't a physical mechanism pushing the Earth. It's literally just an artifact of time measurement. And yet, the author notes, the entire heliocentric wobble relies on matching this totally unconnected time artifact perfectly.
We're going to end this explainer right where the author ends the text, with an open invitation. This provocative question about extreme cosmic coincidences absolutely forces you to rethink what you know. It asks you to look up at the mathematical realities of the universe and decide for yourself, do the accepted models truly make sense of the intricate, ticking clockwork above our heads? What are your thoughts?